So here last class we discussed about the basic latches. So those are nothing but you are getting the outputs in uncontrolled way. So you need to control the outputs. For controlling the outputs, you need to go for gated latches. Okay. So gated latches. So gated latches. If you see, so we'll use a control signal. Okay, we'll use a control signal. Control signal to enable and disable the inputs. To enable or disable input changes. Input changes. So here you have gated set and reset latch. Gated set and reset latch. Okay. So how we are designing means here one more NAND gate you are implementing. This is also one more NAND gate. For this NAND gate, I am giving the inputs as S and R, and one more gated enable I am giving. Okay, this is active high enable. Okay, level trigger. Enable is a level trigger and clock is a edge trigger. Okay, so this is given to one more SR latch, and this will be feedback, and this will be feedback. This will be feedback like this, and this is Qn and Qn bar. This is the present state, and the next state is Qn plus 1 and Qn plus 1 bar. Okay, so how to get the truth table means here you have enable pin, yes, R, and next state, that is Qn plus 1, and next state. Okay, so when enable equal to 0, whatever may be the S and R value, it will be in which state means memory state. It will be like it will be in latch state. Okay, and when enable equal to 1, the latch will be activated. When it is 0 0, so when you are giving 0 0, so that means when S equal to 0, R equal to 0, enable equal to 1. Okay, enable equal to 1 means you know the truth table for NAND gate A, B, and output is Y. 0 0 0 1 1 0 1 1. So any one of the input is 0, output is 1, and all the inputs are 0, inputs are 1, the output is 0. Okay, so here you are getting 1 and 1. Okay, when it is 1 1, what is the state? We already seen SR latch by using NAND gate. Hello.
So when it is 1 1, it is memory state.
Yeah, memory state. This is in latch state, memory state or latch state. Okay. And next, when S equal to 0 and R equal to 1. When S equal to 0, R equal to 1. So 0 1 means this is 1, and 1 1 means 0. For 1 0, for 1 0, this is 0 1. For 1 0, SR latch. What is the state?
For 1 0, it is reset.
Reset state. Here you will get the reset state. Reset state. Okay. And next, when S is 1 and R is 0. So 1 1 means this is 0, and 1 0 means this is 1. For 0 1, what is the state?
0 1, it is set state.
Set state. Yeah, set state. Set state. And next, for so when S is 1 and R is 1, both are 0 only, no? So both are 0.
Both
So
are
when it is 0 0, what is that state?
Is invalid.
Invalid case. Invalid case. Okay, this is the invalid case. So this is the truth table for gated latch. Is it fine?
So when it is enable is equal to 1 only, then the latch is operated, like it is on.
Operated. We are controlling the outputs with the enable pin. So here this is let us say it is in functional mode or it will be in operated. So when enable equal to 0, let us take it will be in off state like this. Okay.
Yes, sir.
Next. Next, gated latch. So you have SR latch. From SR latch, you have D latch. Next, JK latch. From the JK latch, you will get T latch. Okay. So here, here, so gated D latch. Next, if you see the gated delay, or we can call as a data latch, or we D latch. D latch means we can call as a sequential buffer. Whatever the input you are giving, you are getting the output. Just what you are giving means here. So you have SR latch, gated SR latch, no? So this is a gated SR latch. This is enable pin. I have to have enable pin. We already seen this is S and this is R, no? So when S and R are tied together, here we are giving a input called D. Okay, and this I am giving to SR latch, NAND gate SR latch. The output will be feedback, and this output will be feedback, and QN bar. Next state is QN plus 1 and QN plus 1. So here that means which state we are using means when both are tied together means which state, this state and oh, sorry, this is 1 1. This is 1 1. Okay, this state I am using. Okay, so that means no, not this one. One second. This is connected through the inverter. This is connected through the inverter. Okay, connected through the inverter means I'm using this case and this case. Okay, so that means I'm writing the truth table enable D and Qn plus 1 state. Okay, and when enable equal to 0, D input is anything, it will be in which state, latch state.
Latch state only. Like,
Okay, when
hmm.
enable equal to 1 only, it will be active. When D equal to 0, so when D equal to 0, S is 0, R is 1. Okay, and enable
D
is 1.
equal to 0. So 1 minute, when D equal to 0, S equal to 0, R equal to 1, yeah.
It is giving through the inverter, no? We are giving through the
Uh,
inverter. Okay,
so it is
0
zero
1
one. So
means,
it is set state.
yeah, it is set state. It is reset state, no?
So
0
zero
1 means
one.
what? This is 1.
Sorry. 1 0.
1 0
Mm-hmm.
means reset state, no?
Reset state. Huh.
Reset state. Okay, this is reset state. Okay, and when D equal to 1, when
Equal to
D
1, S equal to 1, R equal to 0.
are equal to 0.
So
1 1
0
means
1
0 1.
0 1
Which
is
state?
set
Set
state.
state. First is reset state. Next is reset state. So that means whatever the D value is there, next state will be same now. That's why we call as sequential buffer. Is it fine?
Whatever the D value is, it's showing the same. Okay,
Same
sequential buffer.
value. That is, we can call D flip flop or D latch is a sequential buffer. This is a sequential circuit, and we can call as a buffer. Sequential buffer means Whatever the input you are giving, you are getting the same now. 0
Or
means
else the D
0,
flip
1.
flop.
Yeah, D flip flop is also sequential buffer. Okay.
Yeah, and one more thing, we didn't choose like 0 0 and 1 1 states here. Why?
Why? Because this is connected through the inverter means possible cases are either S equal to 0 or equal to 1 or S
Equal to
equal to
1.
1
Yeah.
or equal to 0. No?
Okay.
Only two possible cases will be there. That will be not there. Okay.
Okay, sir.
Next, gated JK latch. Gated JK latch.
Latches and flip flops are different, sir.
Latch is a level trigger. Flip flop is a edge trigger. Latch is a
Like
means
okay, latches they use enable pin and flip flops they use clock.
yes means
Enable level
suppose we have types of triggerings are there. Types of triggering. Types of triggering means in this you have positive level trigger. One is level trigger. In level trigger again you have positive level trigger and negative level trigger. Okay. Positive level trigger means what? The output will change during this positive level. During this positive level. Okay.
positive level.
That's why I am giving one no. Okay. Negative level means the means it will change during this negative level. This negative level. Okay. During the level either 0 or 1. Okay.
One.
Okay. So means enable pin directly you are giving means this is positive level trigger, and
If
you are
we
giving
are
through the
using not a gate.
bubble means a negative level
Okay.
trigger. Bubble means negative level trigger. Okay. And next you have edge triggering also. Flip
Clock.
flops are edge triggering. Okay. Flip flops again here you have positive edge trigger. Positive edge trigger means what? When the output is changing during this edge. During this edge. This is a clock. This I consider as clock. When it is going from 0 to 1, then only the output will change during this edge. We call as a positive edge. Negative edge means
It is
negative
coming from 1 to 0.
1 to 0. Yeah, it is coming from 1 to 0. It's coming from 1 to 0. Yeah, this is negative level trigger. So now we are discussing about latches. Latches means positive level trigger.
So
Level
in
trigger. I,
latches, this positive level trigger when it is going upwards
yeah, the output will change during this level.
during this latches. Okay, it's the same thing
Latches.
opposite like in negative. Okay.
Negative. Yeah, during this level only the output will change.
Yes, sir.
Okay. Yeah. Last I will tell you the difference. Next, gated JK latch. Gated JK latch. So if you understand this gated these latches, easily you can understand the flip flops. Okay. The means the table will be same only. The difference will come in the enable pin. You have clock. That's it. That only the difference. Okay. JK latch means in SR latch one when it is 1 1, you have invalid case, no?
In one valid case, yes.
Invalid case. That invalid case we are going to overcome in the JK latch. Okay. So how to overcome means you need to draw this JK latch. This is one NAND gate. This is one more NAND gate, and it is given to NAND gate latch, SR latch using NAND gate, and J, and this one is K, and enable pin. This is enable pin. This is connected to, let us take, this is QN and QN bar. This is connected to this one, and this pin is connected to this one, this one. Okay. So here I'm talking about enable. Okay. Enable J, K, Qn, and the next state is Qn plus 1. So when enable equal to 0, whatever may be the J and K, it will be in which state? So it
Memory,
will
I
be
mean
in previous
QN
state,
latch.
Qn, latch state. And I'm checking for three cases, that is 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0. Here the enable case is 1, and 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is 1 only. So suppose so that means when enable equal to 1, okay, let us take j equal to 0, k equal to 0, okay, and let us take qn equal to what? Qn equal to 0 and qn bar is 1, okay. So this will be feedback, no? So this is 1, 1, 1 and 1, 0, 1 NAND operation. Here you will get what?
So 1 minute. QN bar is feedback to J.
Yes,
Okay, okay.
qn bar is feedback to j, okay. So 1, 0, 1 whole bar means what? 0 bar. 0 bar means 1, no? Here 1 will be feedback, no?
Okay, sir.
Here 1 will be feedback. 1 will be feedback. Here you are getting 1 and 0 and 1 whole bar. This is equal to what? 0 bar. This is equal to 1, no?
1,
1. Again 0 will be feedback. 1, 0, 0.
0, 0. It will be 0.
1,
I
no?
mean 1.
1. So for SR latch by using NAND gate, 1, 1 means what? Which case?
1, 1 invalid.
1, 1. 1 second.
Sir, latch. 1, 1 invalid.
Memory state you need to get. Latch state.
Yes, using NAND, right? Yes, sir.
Uh,
Memory state.
memory state using latch. So that means 0 only. So this case, when j equal to 0, k equal to 0, you are getting 0, 1. This is nothing but the state is what? Memory state.
Memory state.
Okay. Similarly, when this is 0, 1, we already checked now. What is the
Uh-huh.
state? Reset state, no?
Reset state.
Reset state. And this is what? Set state.
State.
This is set state. We already seen in the SR latch. So this one we need to check. Okay. This is nothing but toggle state. Okay. So toggle state, how you are getting first? So this state I am checking. Second, yeah, enable is equal to 1 only. Yeah, this case when j equal to 1, k equal to 1, enable equal to 0, and qn bar, let us take qn equal to 0 means qn bar becomes 1. So this will
Sir,
be
enable,
feedback.
if enable is 0, then it is not functioning, right?
Sorry. Enable is 1 only. Enable is 1 only. Enable is 1. Okay. Enable is 1. And qn is 1. Qn bar, it is feedback. And this is 0. So 1, 1, 0. So all ones whole bar. That means here you will get what? 0, no?
0,
And here you will get 1.
1,
Okay. So
0,
when it is
1.
0, 1, what is that state?
It is set state.
set state. So Qn plus 1 becomes 1 and this
1,
becomes 0 now.
0.
Okay. And next case you check. Next case, let us take when Qn is 1, Qn bar is 0. Okay. Now this will be feedback. So that means 0 will be feedback and here 1 will be feedback. Okay. And here this
1,
becomes
1,
1
0,
and
1.
this
This
becomes 0.
becomes 1.
So what is the next state?
So
1
1
0
minute, this
means
1, 1, 1, 0. 1, 0 means it is uh, reset state.
0, this becomes 1. So that means when you are taking the present state as 0, you are getting next state as 1. When you are taking present state as 1, you are getting next state as 0. So
0.
that means that is nothing but we call as toggle state. Whatever the
Getting
unused
opposite.
state is there, we are going to overcome in as a used state in the JK flip-flop. Is it fine? This is a normally characteristic table. Truth table I can write. Okay, enable J, K, and Qn plus 1. So when enable equal to 0, this is truth table. When enable equal to 0, whatever may be j and k, it will be latch state. When enable equal to
12.
1, 0, 1, latch state. When enable equal to 1, uh, 1 second, 0, 0, 0, 0, 0,
0,
1,
1.
reset state.
Reset.
1, 0, set state. 1, this is a 1. And 1,
1, 1.
1,
Toggle.
1, toggle, Qn bar, Qn bar. Is it fine?
Yes, sir. Got it.
Got it? Yeah. And next, gated T latch. So gated T latch, how we'll get from the JK latch only, you'll get the gated T latch when J and K are tied together. Okay. So when J and K are tied together means which cases I need to use this case and this case I need to use. Okay. So here when J and K are connected together, uh, so so first I am drawing the JK latch. So this is enable pin and this is J and K. These both are tied together and this is given to T pin, T input and latch and this is one more latch and this will be feedback and this will be feedback and Qn, Qn bar. So this will be taken from Qn and this will be taken Qn bar and Qn. Okay. So if you see the truth table, enable, okay, and so T and Qn plus 1 state, state, okay. When it is 0, don't care, whatever, which state, latch state,
Given. Given.
Qn. When enable equal to 1, then T equal to 0 means J equal to 0, K equal to 0. Which state?
0, 0, it is memory state.
Memory state. When t equal to 0, latch state or memory state. Okay, latch state. When t equal to 1, that means j equal to 1, k equal to 1. Which state?
1, 1, it is toggle.
Toggle state. So toggle state is
Given
Qn
bar.
bar. This is a toggle state. Toggle state. That is fine. Yeah, any doubt in this? Shall I move forward?
Yes, sir.
Okay, yeah. So next we'll go with flip-flop. So that means we already seen the gated latch, no? So it is easy to understand the flip-flops. So all the flip-flops, characteristic table, excitation table. So for the flip-flop, you have characteristic table, truth table, excitation table, characteristic equation, and state diagram. Okay. So first we'll see SR flip-flop, characteristic and excitation table. So just the difference is here for SR flip flop you are giving only in place of enable you are giving the clock only. Okay. So
Clock.
just I am drawing the block diagram. This is S and R and this is Q and Q bar. Okay. This is my clock, passage of clock. Okay, passage of clock. First, I am drawing the characteristic table. What is characteristic table? S, R, and Qn plus 1. Okay, so S, R, one second. Yes, S, R, Qn. This is Qn. S, R, S, R, Qn, and next is Qn plus 1. Okay, yeah, tell me the cases. 0, 0, 0, 0, 0, 1, and here clock will be there. Okay, here clock will be there. When clock equal to 1, this will be active, and when clock equal to 0, it will be in the previous state. Okay, 0, 1, 0, 0, 1, 1, and next 1, 0, 0, 1, 0, 1, and next 1, 1, 0, 1, 1, 1. This is which state? Memory state, no? This is
First one
reset
memory state.
state. This is
Reset and
set
then
state.
set state.
This is invalid state.
Valid.
Okay, and next truth table S R Qn plus 1, and next state. Okay, so 0, 0, 0, 1, 1, 0, 1, 1. So memory state. Okay, this is memory state, and reset state, set state, and invalid state. Okay. From this you will get the characteristic equation. So that is Qn plus 1, that is equal to summation of m of, tell me the min terms. 1,
Uh,
4, 5.
from this one, you
This table,
one,
characteristic table.
4, 5. That's it, sir.
Plus don't cares of 6
Place
and
don't
7, no?
care 6, 7.
6, 7. Okay. So you need to draw the K map, 3 variable K map. What are the inputs? S, R, Qn, 0, 1, 0, 0, 0, 1, 1, 0, 1, 1, 0, 1, 2, 3, next 4, 5, 6, 7, minterms 1, 4, 5. Depending on the possibility, I can consider don't case as one, no?
Yes, sir. Yes, sir.
So this is one quad and this is one pair. So what is characteristic equation? Characteristic equation, that is Qn plus 1 equal to S plus R bar Qn.
R, R, Q, and yes.
S plus R bar Qn. Okay. And coming to the excitation table is nothing but with present state and next state, you need to get the inputs. You need to get the inputs S and R. Okay. 0, 0, 0, 1, 1, 0, 1, 1. Okay. So, so if you see Qn and Qn plus 1. From the characteristic table only, you will get the excitation values. So when Qn plus 1 are 0, 0, this is first one. Tell me the S and R values.
0 0.
0, 0, 0, 1, no?
0 0 0 1. Yeah.
So this is 0, don't care, can I write?
Hmm.
And next, second, 0, 1, 0, 1. This is
0
second one.
1.
0, 1. 1, 0, no?
1 0.
1, 0, 0, 1. Okay. 1, 0 means, this is 0, 1 means 1, 1, 0. 1, 0 means 0, 1. Again, 1, 1. 1, 1 means two cases you will get. This is 1, 1 and this is 1, 1. 1, 1 means 0, 0, 1,
1
0.
0.
Don't care 0.
So don't get 0.
Don't care 0. Okay. So from the excitation table, you will get the state diagram. You need to draw the state diagram. Okay. State diagram, how to draw the state diagram? So this is present state and this is next state. Okay. So 0, this is the present state and 1 is one more state. You are at 0. What is the next state? It will be in the same state, no? What are the inputs? 0, don't care, no? If present state is 0, what is the next state? 0 only. So what are the inputs? 0, don't care. If present state is 0, it is going to which state? Next state is 1. And what are the
Is
inputs? 1, 0. Okay. And you are at 1. Present state is 1. What is the next state? It is coming to 0. What are the inputs? 0, 1. If present state is 1, next state is the same state,
1.
1. What are the inputs? 0, don't care. So,
Don't get 0. Yeah. Hmm.
characteristic table, truth table, characteristic equation, excitation table, and state diagram. Is it fine?
Yes, sir. Got it.
Okay, good. Next, D flip-flop. D flip-flop. Okay, D flip-flop. First, so if you see the diagram, so diagram D input, so D input and clock. This is Q and Q bar and clock. This is clock. Okay. First, you need to draw the characteristic table. So D, Qn, and Qn plus 1. 0, 0, 0, 1, 1, 0, 1, 1.
1 1.
Whatever the D input, you will get the same value, no? Okay.
Yes,
Next,
sir.
next truth table. So truth table D, Qn plus 1 and state. So when it is 0, 0, reset state. Okay, when it is 1,
It is
1,
1. It is 1
set state, set
section.
state. And next, excitation table. What is characteristic equation? Qn plus 1. Draw the K map, two variable K map. What are the inputs? D and Qn. 0, 1, 0, 1. 0, 0, 1, 1. This is one pair. Qn plus 1 equal to what? D only, no? Qn plus 1 equal to D only, no? D bar,
D
D,
only.
D only. Okay. Excitation table. Qn, Qn plus 1. Next,
D.
D. 0, 0, 0, 1, 1, 0, 1, 1.
1
0, 0 means what? 0, no?
0.
0, 1 means
1.
1. 1 0 0 1 1 1.
1.
State diagram. You are at 0.
0.
Next state is
If you
same
are
state.
good,
What is the input? 0. You are at 0. Next state is 1.
the input
Next state is
is
1.
D1.
Input is 1. Yeah. You are at 1. It will come
Next
to
state is 0.
next state is
Input is 0.
input is 0. Yeah. You are at
1
1.
1.
Same state 1.
Then input 1. Yeah.
1. Okay. Shall I tell JK flip flop and T flip flop?
That is so.
JK flip flop. JK flip flop characteristic table and excitation table. First, JK flip flop will be the block diagram will be like this. So these are the inputs J, K, and T. Sorry, clock, passage of clock, and Q bar. Okay, Q bar. First characteristic table J, K, Qn, and Qn plus 1. Okay, 0, 0, 0, 0,
1
0,
0 0
1,
0 1.
0, 1, 0, 0, 1, 1, and next 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Memory state.
Sir,
Yeah, tell me.
JK latch is like same as SR latch, but we are overcoming that invalid situation with the toggle situation here.
Yes, yes, yeah, that's only the difference.
Sorry,
In SR
reset
flip
set
flop or
and toggle.
in SR flip flop or SR latch, you are getting invalid state, no?
Yes, sir.
So in order to overcome that, means in order to make that as a valid state, we are going to JK flip flop or JK latch. If it is a latch,
Yes, sir.
enable pin is there. If it is a clock, if
It
it is
is.
a flip flop, clock is there. Edge means edge
Okay.
trigger. Okay.
Okay,
Yeah.
sir.
0, 0, 1, 1, and 1, 0. Okay. Characteristic equation Qn plus 1 equal to what? Summation of m of, tell me the midterms.
1 4 5 6.
5, 6. Yeah. So this is three variable K map. What are the inputs? J,
Q
K, Qn
QN
0, 1, 0, 0, 0, 1, 1, 0, 1,
0
1, 0, 1, 2,
2
3.
3
Next 4, 5, 6,
6
7.
7. 1
1,
4 5 6.
5, 6 only. Okay. 7 is not
Only
there, no?
only no 7.
7 is not there. Okay. This is one pair, no?
Pair, and that is one pair.
Corner grouping is allowed. This is one pair.
Corner grouping here.
Okay. Yeah. So Qn plus 1 equal to, tell me the expression. J,
J K bar QN.
Q, Qn bar, no? 0, 0 common.
Okay. You checking that one. Okay. Okay.
K bar Qn. Yeah. K bar Qn. This is characteristic equation. Truth table. J, K, Qn plus 1 state. 0, 0, 0, 1, 1, 0, 1, 1. Qn memory state 0 reset state 1 set state Qn bar toggle state. Okay. Excitation table Qn Qn plus 1 J K 0 0 0 1 1 0 1 1. So when J and K, when Qn and Qn plus 1 are
Plus
0,
1,
0,
0, 0. It is
JK,
0,
tell me,
0, 0, 1, 0. Sorry, 0, 1.
0,
So
1.
0
That
don't,
means
don't care.
0 don't care. Yeah, 0 don't care. And next 0, 1, 0, 1, second one. This is, sorry, this not this one. 0, 1, second one. This is second one. 1, 0, 1, 1. 1 don't care, no?
Don't care, yes.
1, 0. 1, 0 means third one. This is third one. See and tell me.
0, 1,
1,
1, 1.
0, 1, 1, 1.
1, 1.
Don't care 1.
Don't care, 1.
Don't care 1. Yeah. 1, 1,
1 last. And, mhm. 1,
0, 0,
0 and then 0, 0 and then 1, 0.
1, 0. Means don't care 0.
Don't care,
Don't
0.
care 0. Okay. So means you can remember 0 don't care, 1 don't care 1, don't care 0. Or otherwise like this also you can remember 0, 1, don't care.
Care,
Again reverse it will come.
don't,
0, 1, don't care, don't care. Okay. So coming to the state diagram. So during the counter design in synchronous counters, these excitation tables we are using. Okay, you need to
mhm.
remember the excitation table for mainly JK and T flip flop. Mm. And during FSMs, you need to remember the D flip flop. Okay, D flip flop is easy only. Yeah. So you are at zero state. It will be in same state. Zero don't care.
0 don't care.
If we are at a zero, the next state is one.
So 1,
One don't care.
1 don't care.
And you
And
are at
then
one,
0,
zero, don't
don't
care,
care, 1.
one. And it will be in same state. Uh,
Don't care, 0.
don't care, zero. These are the state diagrams. Is it fine?
Yes, sir. Yes, sir.
Yeah. Next, last T flip flop. So after T flip flop, we'll wind up T flip flop. Uh, so so this is the T flip flop. So T flip flop means J and K are tied together. Okay, J and K are tied together, and here you are giving an input T, and this is clock, passage of clock, and Q, and this is Q bar. Okay, Q and Q bar. First characteristic table. Um, T Qn Qn plus 1, 0 0 0 1 1 0 1 1. So this will be same memory state. This will be toggle state.
Toggle
Okay.
state.
So next characteristic equation, by seeing this is looking like XOR gate, no? Or otherwise you can do. For odd number of inputs, you are getting the output as 1, no?
1.
TQN 0 1 0 1 0 1 2 3. Okay. This is 1 1. Okay. If you are getting
Or,
diagonally, this is XOR gate only, or
uh,
that is Qn plus 1 equal to T bar
T,
Qn plus T Qn bar. So this is T XR Qn plus 1. This is the characteristic equation. Okay. Characteristic equation. And next truth table T Qn plus 1 state. Qn plus 1 state. 0 Qn. Which state? Memory
memory
state.
state.
1
1, toggle.
Qn bar toggle state. And next excitation table Qn plus 1 and next T 0 0 0 1 1 0
0
1 1. 0 0 means what?
0
0. 0 1
0
means
1
1.
1
1 0
1
1. 1 1
0. Sorry,
0.
1 0 0.
0. It's like XOR gate only, no?
Target, yes, sir.
Output is XOR gate only. So that means state diagram you can draw. You are at 0. It will be in the same state. What is the input? 0. And you are at 0. It is going to the next state
1
1. And what is the
input
input?
is 1.
1. And you are at 1. Next state is 0. And input is 1. You are at 1.
1 and then it is going to
Same
1
state. Input is 0.
0.
Okay.
Hmm. Yes.
So these are about the flip-flops and gated flip-flops and gated latches and flip-flops.